kids, listen. Today we're going to be solving special parallelograms. And in particular, we're looking at the rectangle. And I want you to know that the rectangle has, being that it is a parallelogram, a rectangle has all the characteristics of every single parallelogram with two added characteristics. As you recall, these are the characteristics of any parallelogram. But the two added ones are in a rectangle, of course. All of the angles, all angles are 90 degrees. That means they're all right angles. And we're going to be using that to answer a lot of questions in a few minutes. The second thing is not only the angles 90 degrees, and let me just draw a picture so we know exactly what I'm talking about. You got a rectangle. While all the characteristics for a parallelogram are true, the angles are always equal. They're 90 degrees. We can't say that about all parallelograms, but the rectangle we can. Not only that, but the two diagonals are congruent to each other. In other words, this diagonal from that corner to that corner is the same length as the diagonal that goes from this corner to this corner. They are congruent. And subsequently, since they're congruent and since the diagonals bisect each other, as we already knew, guess what? This half of the diagonal is congruent to this half of the diagonal. But since the two diagonals are congruent, this and this are also congruent. All four of those halves are the same. Okay, just keep that in the back of your mind as we move along. Now what we're going to do is we're going to work out a problem, like maybe one or two problems together, just as a lesson. So we're going to answer these questions, like finding those lengths. And the first thing I'm going to tell you is that if this is 10, this side is 10. Why? Opposite sides are not only parallel, but opposite sides are congruent in every parallelogram. Likewise, if PQ is 24, and that's the top, then its opposite side, the bottom, is 24. So right now we have two of the answers. I mean, we now know that that QR, which is right here on the left on this side, the right side, QR is 10. And we also know that SR is 24. Awesome. Opposite sides are congruent. Now they want SQ. Well, that's another story. They're looking for this distance right here. And I'm not particularly teaching this, but I'm just kind of thinking out loud. And if I want to find that, it just so happens that remembering and knowing that this is a right angle, and if you could visualize just this triangle alone with nothing else there, and the fact that that angle is a right angle, then that makes this triangle a right triangle. And when it's a right triangle, you can use Pythagorean theorem. Here's what I mean. I'm going to draw this triangle separate from the entire diagram. So if I drew that separately, it might look like this. Where this is 24, and this is 10, and this segment is the hypotenuse from right there. And just like when you're dealing with the Pythagorean theorem, which is a squared plus b squared equals c squared. Now what you need to remember is the fact that the hypotenuse is always c. It doesn't matter which leg is a and which leg is b, as long as the hypotenuse is c. And that's actually what we're looking for, this side, the hypotenuse. So it doesn't matter which one A or B is for the legs. So I'll just call this A, and I'll call this side what? B. And I do my substitution. So a is 24, so instead of a squared, I'm going to put 24 squared. Instead of b squared, I'm going to put 10 squared, and that equals c squared. So if I can calculate that real quick, and you can calculate it yourself, it turns out that c squared, no, I didn't substitute a value for c because I don't have a value. I'm actually looking for c. But when I take 24 squared plus 10 squared, that's going to equal 676. And I know you got jokes, 676. Okay, forget that. But I surely want c. I don't want c squared. So how do you get rid of a square? Well, the inverse operation of square is square root. So whenever you take the square root of a square, you end up with just the whatever the base is, and the base is c, because the square root of c squared is c. But so help, I took the square root just to get rid of the square. But the fact of the matter is, whatever I do to the left side, I have to do the same thing to the right side. I'm going to square root that. And if you take your calculator and find the square root of 676, you find out that it's 26. And use your number sense. Is it viable? Is it plausible that this is 26? Well, yeah, because remember, the hypotenuse is the longest side. If you ever got a number that was less than 24 or less than 10, it couldn't possibly be. It's got the hypotenuse is the longest side, so it has to be greater than either one or the other of the sides. So guess what? We just found the distance from S all the way to Q. And I'm going to put that right there. 26. Yay, we're almost home. Okay. Now, also, since it is a rectangle, the two diagonals are congruent. So if we found this diagonal, we surely have PR, which is also what? You guessed it, 26. Now, knowing that, now listen to this. This is like, please pay attention. Knowing that this diagonal is 26, and also knowing that the diagonals bisect each other, then if you take 26 and divide it by 2, you get 13. So guess what this piece is? And guess what this is? Yep. And not only that, but since both diagonals are equal and bisected, that's 36 and 13 from here to here, and this is 13. So the question is, what is QT, the distance from Q to T? You guessed it, it is what? Amen. 13. Done. Done. Done, done. Now let's take a look at number 3. Number 3 is dealing with just angles. And we're supposed to find all these angles? Holy smokes. Let's take a look and see what we could do. There's so many different approaches to solving this, so there's not just one way. But one thing I'm thinking about, now I'm doing a think aloud, is the fact that, you know, in a rectangle, aren't these right angles right here? Like that's a right angle? And if that's the right angle, then this angle mixed together with this bigger angle, they must be complementary. Because together they add, you know, angle addition postulate, they must add to be 90 because the whole entire angle is 90. But this little angle is 27. So if you want to find the measure of its complement, maybe if we take 90 minus 27. And we all know that 90 minus 27, 90 minus 27 is going to be what? That means that this angle is 63 degrees. Because after all, 63 plus 27 is 90, and that's what they are. And in this problem, another thing that I want you to know, another thing that I see is that since all these halves of these diagonals are the same, you have a bunch of isosceles triangles. Like, for example, look at this isosceles triangle right here. This leg, and this leg are congruent. Did you know when the legs are congruent, then so are their base angles that are opposite congruent. So like if this is 27, that's 27. Afraid so? Look at this is an isosceles triangle because this leg is congruent to this leg. And when the legs are congruent, so are their base angles. So this angle is also 63. Yes, it is. Okay. Another thing that I'm thinking is the fact that, do you remember the triangle sum theorem, which states that the three angles of each triangle, of all triangles, is 180? Well, think about it. If this is 27 and that's 27, can we find this angle right here if we wanted to? I think so. If all three angles add up, I'm just talking about this little triangle right here. If all three angles add up to be 180, how about 27 plus 27? You know, if we did that, we went 27 plus 27. And that equals 54. Then what does this have to do? What does this have to be to make up for 180? So if you take 180 minus 54, you get 126, because we'll say 180 minus 54 equals 126. That angle is 126. And by vertical angles being congruent, this angle is 126 also. Okay, we're about done. Oh, look at this. If this is 63, what does this have to be? Because those two angles together have to add up to be 90. Let me zoom in on it. If this is 63, then that has to be 27, because 90 minus 63 equals 27. So that's 27. These two are complementary. They create that 90-degree angle. And if this leg right here is congruent to this leg, then this has to be 27 also. So 27 plus 27 plus 126, does that up to be 180? Yes, it does. Now there's one more thing. There's one more thing. If I wanted to find this angle, right there, remember this is a linear pair. So if that's 126 from here to here, what is this angle from here to here? Again, that's 180 minus 126. We already know what that is. If we take 180, oops, let's lower that, minus 126, we end up getting 54. Why is that so significant? Because that's what this angle is here. And by vertical angles, this is also 54. And what do you think this angle up in here is going to be? Well, again, if you want to think about it, you could think of like alternate interior angles, and that's 63. But if you weren't sure, you could take, again, 90 minus 27, because these two angles right here add up to be 90. And if this is 27, this is also 63. We found every single one of those angles. Now we have to put the answers in the right place. That's kind of not tricky, but watch. If they're looking for the measure of angle MLK, and you don't know where, sorry, MJK. If you don't know where MJK is, start at M, go to J, and from J, go to K. How many degrees is that? If these are the two sides right there, how many degrees is that angle? Hopefully you'll say 90. Next, they're looking for the measure of angle MJL. If you don't know where MJL is, you start at M, go to J, and then go straight down to L. So it's from here to here and here to here. So let's look at the angle that it's showing me. 63. Perfect. How about JLK? Well, you start at J, go to L, and go to K. So this is from J to K, sorry, from J to L, and then from L to K. What angle's in between there? You got it, 63. Oh, how about KML? So we start at K, go to M, and go to L. So K to M, M to L. K to M, M to L. Which angle's in there? You guessed it, 27. Finally, M and L. Well, from M to N to L, from M to N, N to L. That's this angle right here, which we already found to be 126 degrees. We're done. If you have questions or problems with this, please ask in class. Just raise your hand and say, Cohen, I need help and I don't know what to do, and then just show me where you need help, and I promise you I will get you some help. So as an assignment, we're going to do these two right here, just these two right now, based on what we just saw. And I'm now giving you a chance to get the work in your hands so you can complete this all by yourself. If you could work with a partner, if you need some help, let me know. And I'm going to come back with the do now video. So good luck, and I'll talk to you in a little while.